Welcome to Uptimai, where we revolutionize engineering analysis with advanced features like uncertainty quantification, design of experiments, and sensitivity analysis. Engineers in aerospace and automotive industries often grapple with vast amounts of 2D data, making anomaly detection a daunting task. Misinterpreted data can lead to costly mistakes and inefficiencies. Uptimai is a data analysis and optimization software that helps engineering teams in the auto and aerospace industries make design decisions faster and more accurate by using AI. I am Adam Turchka, and in this video I will show you our new feature regarding generation of digital twins and anomaly detection. For this video, we will use a demonstrative example of a real problem regarding anomaly detection to show the tools that we use to study the anomalies and see the benefits of our solution. The data we will use come from an engine test bench, in which we have multiple sensors analyzing its response, and we will focus on 5 of the most relevant ones. These measured quantities are the vibration of the engine, 2 pressures measured in opposite sites of the component, a temperature and a velocity. Let me introduce Alex Guerrero, who will show us how to do this.
Thank you, Adam, for the introduction, and hi, everybody. The workflow that we followed in this case is to create a digital twin from the measurements for each of these 5 sensors, to be able to predict the response of the sensor, giving any combination of inputs. Once the digital twin is built, the anomalies are easily detected, tracking the differences between the reading of the sensor and the prediction of the model, highlighting the zones where we should investigate further. Going to our software, we can see at the beginning the relationship between the different sensors in the form of a Pearson correlation matrix, which gives us a first impression of how the different outputs behave. In this example, we can see that these 2 sensors, pressure 1 and pressure 2, are highly correlated with each other, and also they are negatively correlated with velocity, which means that when we have an increase on pressure 2, we will have a decrease on velocity. We can also see how the temperature doesn't get affected by the other outputs at all, which makes it an independent variable. In case we want to see more details about a specific digital twin, we can do it by clicking its name in the screen, which will redirect us to a page with all the information of the specific output. Here we can understand how the sensor is behaving, and thanks to that, we can improve and optimize its behavior. Inside the digital twin, we can also have a quick access to a view of the existing anomalies of the specific sensor. Aside from the model itself, when there are very characteristic correlations between models, it is interesting to see exactly how they are looking in more detail. This we can do with the Compare Output feature, for example in here with the interaction between 2 pressures. We can quickly see that all the samples are in a straight line as these 2 outputs are very correlated. Also, we can see the error from both outputs at the same time, quickly depicting anomalies. In this case, there are 4 positions that we have an anomalous behavior. 3 of them are happening on both pressures at the same time, which can be, for example, an error of the preparation of the experiment, or that it hasn't achieved yet a steady condition, while the last one, the error is only happening on one sensor, showing that it may have been a possible overcharge or something wrong, specifically with that sensor, which should be investigated further. Going back, we also have the Pearson correlation from anomalies, which is a table that tells the probability that the anomalies between 2 sensors are related to each other. In this case, we can see that the anomalies on velocity does not have anything to do with other anomalies happening on other sensors, which may indicate that the problems are not global. On the other hand, we have a quite large correlation of anomalies on the pressures we saw before. Finally, to have a global overview of where the anomalies are in all the sensors at the same time, we have the Anomalies Position feature, which indicates for every moment in time if there has been an anomaly or not, for all the sensors appearing.
So, as a summary, in this video we saw how we can use inbuilt digital twins to detect anomalies, and how to extract all the details to be able to prevent them in the future. With that analysis, we can investigate the causes of our anomalies and get some insights from it to understand why these are happening. Also, thanks to the digital twin, we can predict how the sensors should behave, having a deeper understanding of the problem itself and how it could be improved. Thank you for listening, and remember that you have more detailed information in the documentation section of Uptimai website.